A very good afternoon to all of you. I'm Ankita Chauhan from NASSCOM Product Council, and I'm back with another interesting episode from our data science series. I have with me Amit Kapoor, who is the founder partner at NarrativeVIZ Consulting, and will be sharing his knowledge and experience on the topic interactive data visualization. This will be an interactive session, so please be curious, ask questions anytime during the webinar, and Amit will take up all the doubts in between his presentation. Plus, do not forget to leave your feedback post the session. Will take only a few seconds, but will help us improve the future episodes for sure. Over to you, Amit.
Okay, thank you, Ankita. Um, Hi, good afternoon, everyone. So the session is titled Interactive Data Visualization. It's kind of a big topic, but we'll kind of walk through a few of the elements that I thought would be interesting for the set of participants here, and then maybe go down some different tracks based on the set of questions you ask, right? I have to put this disclaimer up. First, at least from the NASSCOM side, that this is primarily a webinar for educational purposes, and we're just trying to help here, try to educate on how we can use these different topics or different viewpoints in your own application or business or services, right? Interactive data visualization. Let me just do a quick introduction for myself. My name is Amit Kapoor. You can pretty much find me on the web at amitcaps.com or at amitcaps pretty much on most social media channels. And my primary interest lies in this intersection of data, stories, and visuals. So I've been a management consultant pretty much in the last decade, and I was primarily trying to get clients in a consulting environment to make something or make a change happen, right? Or change where their direction of where they're going or the velocity of where they're going. And as part of that, we would primarily use a lot of data-driven analytics to guide their interactions. And then both in the analysis of it and in the communication of it, use visualization and storytelling to kind of show the possibilities and persuade people to go down that path, right? So that's where a lot of my background stems from. And in this decade, I've primarily been kind of looking at this intersection of data, stories, and visuals, and trying to think about how to do this in different contexts. So different storytelling context, data visualization context, consulting context, more recently, machine learning and deep learning context. And I'll try and touch on some of these topics to say where visualization can probably come in to play a part in that, right? And as Ankita mentioned, feel free to kind of shoot questions across the chat, and we'll take it. Ankita will kind of prompt me when there is a question that I can probably pick up, and depending on what you say, we may take different directions on this webinar. Right. So let's start with this first question of why are we talking about this, right? I used to. We kind of think a lot of in the world now that we want to look at data analysis or take a data-driven lens to this problem or any problem. And we focus a lot, or at least in my case, I used to focus a lot on this analysis. Are we doing the right analysis? Do we have the right numbers? Do we have the right arguments to make, right? And what I realized in my experience is that we need to kind of switch our hat from thinking more about analysis or numbers or arguments to how do we synthesize that analysis into some insight? How do we communicate that not as numbers but as visualizations or visuals? And how do we convert what would be an argument into much more a story, right? And these are the three elements that I kind of want to hit on in this coming 45 minutes or so, right? So let's start with the visualization, right? So what is visualization? Let's pose this question: what is visualization? So we can think of this visualization that's happening, or a process that's happening, right? Somebody swinging on a branch of tree, on a pendulum, kind of like a pendulum, but a tire pendulum. And we are trying to understand that process, right? And we can understand that process through a symbolic lens, which is kind of the equation at the bottom, a set of numbers that we're trying to look at and see how the swing is going, or what the amplitude of the swing is. Or we could look at it from a visual abstraction, right? So we could think of it as a set of visualizations which kind of communicate and help us understand what is happening in the phenomena, probably a little more easily than the symbolic one, right? So both have their places. The symbolic one has a power in terms of trying to think about visualization, or help in condensing the whole process very nicely. But you can think of the visual one as something that may be a little more easier to communicate, a little more easier to amplify cognition, right? So we want to harness this visual abstraction that is easier for us to understand, and that's why we want to think about visualization. So let's take it a little more concrete. This is kind of my favorite examples, and I use it quite often in my trainings and workshops. How many ways can you visualize this set of tables, right? So we have pretty much the most simplest data set that people would have played with. So you have area and sales, so two numbers, and we have 5 areas: north, east, west, south, central, and we have sales, right? 5, 25, 15, 20, 10. And I guess the question to everyone on the webinar is, if you were to look at this number, or had a paper and pen and were trying to visualize it, how many ways can you think about visualizing this? I'm going to give a pause for about 30 seconds or so. And people who are listening can kind of write in the chat and say how many ways can they think of? Is it 2, 3?
There are 2 answers. They're saying 2. One is saying column chart, one is saying bar chart, pie chart. So yeah, we have bar chart is high on the number. Then map chart. One is saying multiple ways can be represented in any type of graphs. And one is saying donut.
Donut, okay.
Yeah.
And if I was to ask the question, how many ways? So not just a particular way, but how many ways can you think of?
When I say ascending trend, and with perpendicular lines, and they're saying 2 ways.
Okay, 2 ways.
2-dimensional chart.
5 or 10.
All right, most of them are vouching for 2 as of now. Then one is saying bubble chart, column chart.
Okay, so we are obviously familiar with maybe some of the common visualizations, right? And we can think of those really quickly and say, okay, let's put this in a column chart, or let's put this in a bar chart, right? But if you were to break this process down and say, what are we trying to do in visualization, right? Yes, charts is kind of like a template to do this, right? So as long as I know my data is going to fit that template, and I feel that chart can represent this data, and I feel the data is in the form the template will take, we can think about mixing the two, right? But let's think about it in a different way. So the process of visualization is essentially converting symbols into geometry, right? That's the core. It is just a transformation of taking symbols, in this case these numbers, and converting into geometry, right? So now if I think from a geometric perspective and say, how can I translate this into geometry? I may think of the different ways to think about this, right? I want to represent the geometry as a point, as a line, as maybe a bar, right? As a bar that's not actually individual but stacked on each other, right? Or a bar that is staggered, or so 5 different ways that I can think of geometry. And I can then think of, okay, I need to put this geometry in some coordinate system, so I'm going to put it on X and Y coordinate systems, for example. And if I do this, I can think of 5 different ways to visualize this, right? I mean, they are the identical data, but visualized in 5 different ways. The line chart is strictly not a line chart. I mean, it's like a thin bar chart, but I'm gonna leave it at the moment with that thing. But we have a dot plot, a line chart, a column chart, a stacked column, and a waterfall, right? And people may be wondering, okay, so I don't have the bar chart here, I have a column chart, so how do we do? Well, we can cheat like most templates cheat and say, let's flip the coordinate system. And if we flip the coordinate system, we can start to think of another 5 ways to do it, right? So we now have the same thing, I mean, dot line, but now we call it bar instead of column. We think of stacked column, stacked bar. There's technically nothing like a waterfall on XY versus YX, so we come up with some new names, right? Cascade. So we can think of about 10 fairly easily, right? How do we do? Somebody said donut, or somebody said pie charts. Well, what's a pie chart really? Well, a pie chart is actually something not on an X and Y coordinate, but on a angular coordinate, right? So on a radial coordinate system. So X is mapped to radius, Y is mapped to theta, or X is mapped to theta, Y is mapped to radius in this case. And now we're just changing the coordinate system, leaving everything like it is. And we can start to see 5 more visualizations of this. So we have...
Amit, here there's a question. Can I interrupt you?
Yeah, sure, please.
If we have geodata, we can represent it in a heat map. I think that would be a better visualization. I think it's a statement more of a question.
Yeah, so let's think of what is geo, right? So right now we had X and Y coordinate. We have X is equal to theta, or radial coordinate, which is what's showing on the screen. Now, a geo mapping is effectively the same thing. It is mapping instead of coordinate system. I want to use a lat long coordinate system. So I want to map the same data on a latitude, longitude. And I want to use the coordinate system and represent the, because you mentioned heat map, I want to represent the data as an area which is colored by the value of sales, right? So what we're kind of talking here and is just another coordinate system, right? So I'm now mapping instead of radial coordinate systems, and we have these charts. We're now thinking of how to map it in a spatial coordinate system, right? And I think charts, or thinking about charts, is one way to think about it, and I'll come to how to think about it. What I'm walking through right now is more kind of the underlying process of it, which is inherently called the grammar of graphics. And it is basically thinking of how I transform numbers into shapes and I map it to different aspects, right? So coordinate systems is one, the mark, or how I map it to a different element, is one. How do I map it to scales is another thing. So we have a few kind of a rendering pipeline, and based on that, we can convert a map. And I'll probably walk through a bit of this later on to show this.
There's another question, Amit.
Sure.
How to decide which one to use, or which representation will be more appropriate?
Okay, so let's look through. Okay, I'm going to show another one. So let me show X equal to R, Y is equal to theta. So now we have the same data represented, and we have now our favorite pie chart. So we've got about 20 of these visual representations, right? And okay, I'm going to slowly flip through it once. So these are the 5 on X and Y. These are on Y and X. These are on X is theta, Y is R. Second is X is R, Y is theta, right? Okay, let's ask people, which is the one that people think they would pick as the one best representing this data?
XY, bar chart,
XY,
bar
bar chart,
chart.
bar chart. Okay, so this one on the right. Any more responses?
Most of them are vouching for bar chart.
Okay, very nice.
And one is polar cascades.
Polar cascades. Oh wow, okay. Didn't expect that.
And pi.
Pi. Okay, yeah, pi. Everyone's favorite pi.
Then for easy understanding, line and bar chart will be really good. Stacked bar.
Stacked bar. Yeah, that's pi and that's basically pi. I mean, a stacked bar and a pie chart are same other than the coordinate system, but yes.
There's one windrows polar.
Windrows polar. Okay, windrows and polar. Okay. Okay, so let's answer this question, like a little bit of thought, right? So people are picking things which they think they can understand, right? So I said visualization is the process of transferring symbolic into geometry or encoding data into visual representation. But when you are communicating, there is an audience there that has to then decode it back, right? So if you think of the process as encoding is what we are doing, and when we present this or use it for communication, then the audience is trying to decode it, right? So what is the process that is easy for somebody to decode? How do we find that out, right? So there is obviously perception guidelines on what people find easier to decode. And I think a lot of answers said bar charts because bars are easy to compare on similar axes. And length, or if you think of the encoding, the length is actually easier for people to decode. And hence you would typically prefer bar chart in this context. But if the context was to understand how big the sales is or what percentage of the sales is as part of something, then something like a stacked bar could also work, or even pies could work with just 4 or 5, right? So the task of visualization is twofold. One, I want to understand the data, and hence I map it into a visual representation because I can probably understand it far more easily. But if I'm really trying to communicate using that, then I also want to keep into mind what is easy for people to decode, including myself as a person, as a user of that chart, right? And in that decoding, I will look at what is from visual perception easy to decode. So there is an order typically, at least for static charts, length, position is the easiest, followed by length, followed by angle, at least for quantitative data. So I tend to go with that. There is also a thing about visual literacy. Is this a chart that people have seen a number of times and then they understand what it means? Or is it a very new representation, which means I may have to educate them about it, right? That's number 2. The third is the context in which I'm sharing, right? If I'm sharing a slide, or like right now, but I'm giving you 5 or literally 3 or 4 minutes to look at the slide, you can build that context, you can spend some time and understand it, right? But if I'm talking in a conference setting or in a one-to-many setting and I'm really going through slides fairly quickly, I may want visualizations that are easier to understand, right? But if it's a dashboard where people will repeatedly look at the visualization, so something complex but more appropriate for the data can also work, right? So I can actually go down that path and actually help people to learn that visualization, right? So if I was to kind of unpack this a bit, your task is not only to focus on the encoding, which is what you would do as creating a data visualization, but also to understand what part of that decoding will be easier for the audience and appropriate for the audience context, appropriate for the purpose, appropriate for the task at hand, right? And if we think of visualization as both the encoding process and the decoding process, then we can think of how we can create many visualizations, like we just did 20, or including geographic and all. We can actually have unlimited visualization through this process, but we then have a way to kind of tune it down and say how many of them do we really want to select, right? Does that help address the question? Any follow-ups?
Yeah, there are a few questions. So I'll just start by Akhil is asking you, how do you visualize intangibles? Because in the end, every industry come down to this point, like experience, satisfaction, anxiety, competition, personal growth. How do you set the bar for comparative analysis?
Okay, good question. So let's go to the let me drill to a next definition of visualization, and I kind of come to answer that question, right? So we're trying learning to see, and I think this is a better definition of visualization. The visualization is the use of computer generated in this context, and these days, like, we rarely do it paper and pen, given the size of data most of us will work with. Interactive, more and more increasingly. Visual representation, that's what we talked about, of abstract data, okay, to amplify cognition, right? So I'm going to stress on two words: abstract data and amplify cognition, right? So Akhil's question on, I have something intangible I want to represent, right? Well, sales is also intangible, right? Area is also intangible. We are focusing on abstract data in the sense the data itself doesn't have a shape. If you go and do an MRI, for example, and that's kind of somebody's doing an MRI of an arm, the arm already has a shape, so I don't have to give it any shape. That's more in the realm traditionally called scientific visualization, because the shape already exists and I'm not so much focused on giving it a new shape. But in business, in many contexts, maybe spatial data is a bit exception, but any other context, you won't have a shape to give to the data. So the data itself has an abstract. And the task of visualization becomes finding an appropriate shape for it that represents that, right? So everything is intangible. Can I choose a shape? So in this last example that we were doing, if I go back, why am I not using, literally a cash or money to represent, right? Why I'm not using a rectangle, or a rectangle with a photo of cash, right? To represent sales. I can choose any visual representation to do it, and then see if I can translate it back into something that people can decode, right? So your question on intangibles, it basically means, how do I represent that intangible emotionally, right? So is there a visual metaphor that I can find that represents that much better than maybe the simple glyphs that we're seeing right now on the page? So I don't want to represent point or line or bar or area, but I want to create some complicated or more nuanced glyph which capture this much better, right? I think maybe I'll point to a few more examples. I didn't include any examples much more on kind of the information visualization, but you can take a lot of inspiration from work done in many different contexts. So maybe I should just pick one and see if I can show an example. Okay. While I pull this up, Ankita, is there any question? Any other questions? Sorry.
Yeah, I have. What will be the suitable type in case the number of items to visualize is more? For example, 10 different states sales.
Okay. So again, a hard question to answer, but I'll pick it up with the same example, right? So if you look at this example, this is intangibles. I'm trying to represent, this is a fantastic chart done by Moritz Steffner on OECD Better Life. And it talks about visualizing multidimensional data, right? So that's kind of the second question that you just asked. And the first question of Akhil's, how do I represent many aspects? So I'm representing 11 aspects here, or not me, the creator. housing, income, job, community, education, environmental, civic engagement, and so on, right? And each country is rated on it in this kind of glyph manner, where the petal basically shows, the color of the petal shows the type, and the size of the petal shows how well they do it, right? And then we can even weight them differently, and you'll see the petals turn, and we can even weight them. But the idea is this is multidimensional data. I'm showing 11 different data points. I am not using a circle or a point, but in visualization, we call this a glyph. I'm creating a glyph that kind of shows all these 11 aspects. Now, for about 20, 25 countries that are there in OECD, and for this representation, this is fine. I can understand, I can look at multidimensional data and kind of change my weightage, see how the countries change as I change the weightages, and make some decision on it. If I have more data points, then yes, glyphs or complicated glyphs like this will not scale well. And then we will have to go to other techniques like faceting or interaction or interactive views or dimensionality reduction to kind of think about how to represent it. But for small data, it's very easy to think about newer visualizations that can kind of represent this a little better, right? And this is intangible, right?
Yeah.
Go ahead.
Yeah, there's one question by Krishna. How do you categorize the graphs? As you said, it depends on the person we present. Do you have a defined chart for this? Well, I know this is crazy, but I don't see any other graphs than stacked pie bar. When do we see radar?
Yeah, where do you really see radar? Is that okay? Okay, so let's look at, there are many chart classification libraries, trying to classify different types of charts. I will take you through one of them that kind of illustrates my way of thinking about it. So let me stress on what we're trying to do here. We're trying to amplify cognition, right? We want people to understand better, right? Cognition is very related to perception. When we say I see something or I understand something, I really mean I understand something. I can see what you're saying, right? So the purpose of visualization is to amplify cognition, mine or somebody else's, right? Now, somebody said, okay, the grammar is really hard. I can create unlimited charts, but it's, how do I actually go beyond that, right? So how do I get into chart categories, which helps me think about what it is, right? So let's think from questions. I want to answer questions, and visualization is great because it can help you answer questions that you didn't know you had, right? That's one of the reasons we do visualization, right? We kind of talk about it as addressing the second level of ignorance. I know what I don't know. If I know what I don't know, I can probably go and find it. But visualization is really powerful when I don't know what I don't know. And if I don't know what I don't know, I really need to see the data, right? So let's think from a question perspective. And this is just one way to think about chart taxonomies or chart categories. And there are a few wonderful ones, which I will also point out to if you don't like this one. So what are the questions? Questions are who and what, how many, where, when, how, why. So, these are questions. And I can ask, I can ask all my questions to data, and then I want to think about chart representations that do that, right? So one example, and I'm going to just go through one of each just to give you a sense of it. So who and what questions are really trying to look at what's my distribution of data, right? How does my data really look like? Can I create a portrait of the data? If the data was a person, how would the person look like? I want to see the distribution of the data, and that's a very common task that everyone does in visualization. So here, for example, is a visualization that's really looking at distribution, right? So I'm looking at plotting distribution. I'm looking at different M&A deals in different sectors, and I'm looking at what was the M&A premium, capability premium that they define as a metric compared to various deals, right? So I'm really looking at that every deal has some premium percentage, And this, you can think of it as it is a dot plot, but technically it's just a histogram, which are very, I mean, it's a version of histogram. And I'm really looking at how the data is distributed, and that distribution can help me understand a little bit more, right? Um, and this is really the portrait of the data I'm trying to do. Very common first task in most data analysis kind of thing, right? But here it's used for communication. So second, which is what I guess the question was, comparison, right? How many of these are there? Now, this is the second most common task that you would do. I really want to understand the comparison of my data. How does different aspects compare, or different data points compare, right? So this is, for example, a working capital profiler, looking at different companies, looking at their account receivable, account payable, inventory, and benchmarking them into different quartiles. And I'm really comparing, okay, where does my company stack, and what's my potential to improve in any one of them, right? So I'm using, again, to compare and benchmark, but the idea is I want to really compare this blue bar, which is representative of the company that I've chosen, versus everything else that is there, right? So I want to see the comparison of where this stacks up, and comparison is another common task of this. The third is I want to see position in space. So I want to see where everything stacks up. Now, position in space, if you're not using data visualization, but if you're just doing idea visualization, everybody who's seen a 2x2 chart is basically trying to position something in space. But when we talk in DataViz, we're basically talking about spatial charts and how we can think about that. And here's an example of wind map. It's basically wind flowing through every data point in every place in the US, and it's interactive. You can actually zoom into it, but it's representing wind, and it's using motion as a way. So the encoding is not a point or a line. It is a line, but it's motion. And this is, I think, an example of when Sandy, 2012, when the Hurricane Sandy hit New York. And you can see wind speeds of very, very high wind speeds in the New York area, especially that's happening. So this is visualizing. I'm visualizing in the space. So I have the lat and long coordinates to represent it, which is what somebody had mentioned earlier. And now we are really looking at this and seeing the data in the context of the space, right? The fourth example, or the fourth category you can think of as timeline, position in space. A position in time, sorry. So we have position in space, now we have position in time. We are answering the question, when did something happen, right? And I look at this chart. I mean, line charts, or this is very common in business. We want to look at time, and you want to plot a line chart. And this is a fantastic example from New York Times about looking at how meat consumption has changed over the 100 years. And the reason I like this chart is not just because it represents time, and you can clearly see the three highlighted lines, or the three lines in prominence: beef, chicken, or at least beef and chicken are the most prominent ones. And you can clearly see beef going up and then coming down in the US, pork being fairly flat and chicken really rising. But what's really makes this chart really pop out is not just the line chart, but also the annotation, the markings, the different layers of timelines that have been put here. So to provide people context to it, titling, story, that element that is there, a century of meat, and a kind of a small story about what it's been showing. And so this is a fantastic example of a timeline chart, which is not only telling me the data plotted in time, but also fantastically communicating through annotation and different layers how it works, right?
Can I
Sorry, go ahead. Yeah,
interrupt? Yeah, there's another question. Do we have to map the visualization item in the dashboard to a KPI always? If yes, could you please suggest a methodology? I struggle to convince stakeholders with right backing KPIs for each widget/data.
Okay. So I think we need to think about what the purpose of the dashboard is, right? Is there a methodology for creating dashboards? I mean, most dashboards are pretty sloppily constructed, right? We put all the 4 KPIs on the top, put 4 charts, add more details to the bottom, and we say this is now a dashboard. And in essence, what you want, I think you need to think a little more deeply about what is the purpose of the dashboard, right? If it is a monitoring dashboard, which is technically what Stephen Few will call a dashboard. I want to use it for monitoring, and I really want to see whether the performance is going up and down, active monitoring. Then yes, having the KPI numbers and having a guide, the change in the KPI number over time could be a good representation. But in many cases, we kind of broadly use dashboards as not just a monitoring dashboard, like a log analysis, or what the performance is minute by minute. For operational purposes, we want to use the dashboards as a way to communicate, and I think that's where it kind of gets messy a bit. So again, go back to what is the purpose of the visualization. What am I trying to communicate? If it is monitoring, then yes, focus on the KPI and how the KPI changes over time, and that could very well be all you need. But if the purpose is to help people understand what's happening in the process, right? I want people to be able to investigate why something's not working. And then you may actually have to choose a very different way to think about this, right? So how do I provide an overview of the entire process that people can understand everything that's happening? So overview of the data, and then allow people to filter stuff or zoom in into details as you are. And then you really focus on, can I map the mental model of the process, or mental model of what's actually happening in the real life, to the data model, and use that visual representation. And you may come up with different representations to do it, right? I don't know if that kind of helps, but most dashboards if you put more thought about it, what you're trying to communicate, and not just an operational dashboard, you'd probably be further in that direction than just kind of creating something that's a little bit of putting charts together in a composition and be done with it, right? So you need to really map the mental model of what's happening, or what the question people want to ask, to the design of the dashboard, understanding what the purpose is: strategic, tactical, and operational. Yeah. Any more, Ankita, or should I?
Yeah. What visualization would be best suited for exception highlighting, that is, the ones performing less than exception?
So yeah, in one way you're trying to show deviation, right? And exception highlighting, I mean, one rule is, one way to think about this is, I want to show a deviation from something, either deviation from a target or deviation from norm. You can think of exception also as sometimes in outlier, and think of representations that work really well for outliers, right? So if I go back, I mean, I don't have many representations in this chart, but if I was just showing something that's outlier, which is in the 138% here, or 1 minus 130% here, then this portrait could really work already as a deviation, right? And I can kind of show that. If my data is over time, and I was trying to show deviation over timeline or a target, I may not actually be interested in showing the line for chicken here or beef. I would probably show what the target line of beef is, and what's the deviation from that, right? And then really show when the exception or the outlier is happening, right? So again, it depends really much on what your purpose is, but outlier data representation or exception is a very common thing. So how far am I away from a target? How far am I away from normal data? And depending on the type of data you could pick a representation that fits it. So which may require you to transform the data and not just represent the data the way it's collected, but take deltas from the target or take deltas from a norm and say how far are we away from that norm to represent it. Right? That's typically one easy way to think about it. And depending on the context, you may experiment with more. Right?
Amit, there are a few more questions.
Sure. Go ahead.
But would you want to finish this slide and then we could take up those questions?
Okay, so let me cover a few more topics. Just finish this wagon wheel.
Yeah.
So flowcharts, a lot of data can be relationship or have hierarchy in it, and you want to think about how to represent that data. And flowcharts is one way to do this. And I'll dig deeper into this example just as somebody thinking about interactive visualization and how we create it. But this is basically something I created a couple of years back when demonetization was really on the in vogue or had happened. And there was this whole talk about how much money is being spent is in the 500 and the 1,000 rupee notes. And I wanted to really look at how we can visualize it in a way that communicates that really well, right? So it has a bit of animation. It has a bit of, what's called like a tree map representation. So, each side of the notes represent, each sides of the rectangle represent how much number of notes are in circulation. And you can clearly see the trend in terms of how maybe in the early 80s, we had 100 rupee notes, but 150 were dominant, but not as much. And then we started to have 500 and 1,000. And when demonetization really happened in 2018, 2017, right? We can see it was nearly 83% or so of the total share of market of notes in circulation, and that's why it hit us much more worse than it would have if it was a less amount of money circulated through that. And the last one is really trying to think about deduction and prediction. And I really want to show stuff that people have. I want to deduce something. I want people to take away something. I want them to establish some correlation, some causation. And this is a classic example, inspired by Hans Rosling's, talk, which, all of you should see on Storytelling with Data, but really talks about health and wealth of nations. And each circle represents a country, and we can see the wealth of the countries going up. Health of countries improving as the wealth is going over 200 years, right? And this is more kind of a representation which is a little more interactive of that and shows that, right? So this is one way to think about it. What is the task of visualization, and how do I create something that represents either the distribution, the comparison, the map, the timeline, relationship, or deduction prediction. And one of the things that we normally do very well in visualization is focus a lot on kind of just showing portraits or comparison, and they're really effective. But we don't focus that much on questions of why, right? We focus a lot of questions of how many and who and what. And one of the ways to start to think more deeply about visualization is to see, can I map not just who and what and how and many, but also think about why something is happening and use visualization as a way to augment that, right? And if you do that, then there's possibility to kind of go deeper into that. Okay, so before I go a little further, Ankita, any questions? Yeah, you had some questions that you wanted to share.
Yeah, just a sec. Can you explain box whiskers with examples?
Yes, okay, let's park that in a moment, because I think statistical charts are interesting. And if you think about box and whisker, they're basically portrait representation. So I want to represent the data as a portrait, but I don't want to represent in the entire data. Okay, so because the data is quite huge. So what do? I convert my data into, think about it in terms of quartiles. So I know what is 0%, or what is at least, let's say, first quartile, second quartile, third quartile, right? And now I have the data, I have the distribution of the data, but I'm now showing the data as quartiles. And to do that, I create the boxes. And the box basically kind of shows first quartile, median, and third quartile, right? So that's my box. And whiskers are then just trying to show how far does my data go outside it. And I want to maybe show the whisker. So I would typically take my interquartile range and show 1.5 the interquartile range as a whisker. So it's basically taking my data for any column, converting it into quartile data. So I know what the median is, what the first quartile and the third quartile is. And I use that to represent it in a visual way, using a box to represent the first, median, and quartile, and the third quartile, and the whisker to show how much data is outside that, which is typically taken as 1.5 the IQR, right? So it's two charts combined together, or two representation, but ultimately a portrait chart. Yeah.
All right, thanks. The other question is, does virtual reality have a huge potential for data visualization where users can interact with data in a third dimension? Like we pick a data set and move it around on any axis and have a different interpretation.
So we are really in the we're really in the early stages of doing any visualization or any serious kind of visualization in the AR or VR space, right? People are obviously exploring it. In traditional static visualization or interactive, in this kind of screen-based visualization, we don't tend to do a lot of 3D visualization for abstract data because there is a lot of problem in occlusion and all that, right? Potentially in AR and VR, some of that stuff can be mitigated. And hence there should be scope for like a Jarvis kind of visualization from Iron Man, show me all the data around and all that. But most of the research in this is very preliminary. And I think we may not, definitely you'll see far more progresses in other spaces looking at visualization solutions before you will see data visualization coming into play there, right? Yeah, personally, I haven't dug too deep in it, but even recent IEEE, there are a few talks now emerging on AR, VR, and we're still pretty far behind in exploring that medium in any significant way. Yeah.
All right. The other question is, Amit, there are a pool of many questions. So if you have something very important to, share or discuss, we can go ahead because there are just questions coming in.
Okay, no, sure. It's okay. We can keep it. I will, yeah, we have 20 minutes. Okay, let me talk through one concept more, and then I'll kind of take more questions, right? I want to talk about the role of visualization in the analytical process, right? I teach a lot of machine learning, deep learning, data analytics, and I just wanted to kind of talk about how to think about this, right? So I think visualization plays a critical part in the entire pipeline of doing any data analytics. You mostly want to frame a question correctly. So how do I take an unstructured problem and frame it into a question that I can solve analytically? And there, it may not be data visualization so much, but idea visualization and cognitive visualization to say, how do I map the idea onto, something that's structured? I want to get something that defines a problem really well. So in framing, that's really important. It's also important once I start to acquire the data and I start to clean it up. There's not enough talk about this, but how do I understand where this data is coming? What assumptions have been made in the data? What is the lineage of the data? How clean is the data? Right. So again, visualization as a way to understand this is really important. And some tools are there that kind of trying to do a lot more on this database for acquisition of data or data lineage or showing relationships, but we can do much more. Then obviously in exploration, so I want to explore the data. What are the aspects of data that are really understand the data really well, and that's where visualization shines. So exploratory data analysis. And then we come to transforming the data and modeling it. And again, trying to understand the model is equally important. So we want to think about model visualization. How can I visualize the model in a way that helps me understand the assumptions that the model is making or where the model is breaking, right? And then finally, in insight communication, I want to convert my data into insight. Nobody's going to understand the model. Nobody probably understands the model in the data itself. I want to connect my insight back to the question that I was trying to answer. And hence, Viz for communication becomes really important, right? So I'm going to quickly go through a few examples just to highlight this, and then we can take more questions, right? So, I talked about, data validation or refining data, and one of the things you want to understand is, how clean my data is, where are the valid data, where is mismatched, and this there's a tool like Trifacta which does this, but many tools look at this. Open Refine is another one. But the process of data validation, data lineage becomes really important. Obviously exploration, and I want to look data in, like here for example is secondary freight data, and I want to understand how my freight movements is happening from which DC to another, which loading point. And this is something I created using some open source mapping tools like Kepler.jl from the Uber community, open source community, and is really looking at visualizing spatial data and help me understand the network and what's really happening. So, exploration really becomes important. Model visualization is going to be becoming even more important as we focus much more on complex models, or how do we unpack these models. And there are obviously techniques to do this. One of the techniques is to see how much my model answers changes based on changing the inputs. So I can probably visualize every data input and see when I change one particular element, which is selecting right now, and I change one parameter of it, what happens to my answer, right? So, understanding model and model interpretation will also become a very important key part of it. And the final thing is I want to help people use visualization to develop insight, right? So here, example of A/B testing. But I created some A/B testing, and now I want to use visualization to help people understand what is happening and see what happens if you make different assumptions, right? So I want to convert and use visualization to kind of go back to that, right? Okay, so even though we've been talking about visual creation and we've been talking about grammar way, we're talking about charts to do it, I want to emphasize that visualization plays a critical part in each of these elements. And whether you're doing data acquisition, whether you're doing EDA, whether you're doing model building, whether you're doing insight for communication, you need to think about how to represent the data in a way that accentuates that task, right? Makes it easy for you to do that task. Okay. I mean, I can cover more stuff, but it'd be probably helpful to pick a few more questions before we nearly run out of time. So, Ankita, any more questions? Yeah, you wanted to share.
Hitesh has a question for you. Z-score based circulation are more effective, accurate than relative representation.
I didn't get that. So, what is more accurate than relative representation?
Z-score. Z-score.
Z-score.
Based circulation. Calculation.
Yeah, okay. So I think we're not really comparing numeric approaches to visual approaches. They're highly complementary, right? So you're looking at outliers and you want to use Z-score calculations to say what is outlier. Sure, go ahead. I mean, there are many ways to look at outliers, and you can think of Z-score as one numeric way to think about outlier detection. There obviously it doesn't really work in multidimensional data, but for a single dimension, it can be an effective way. But we are really talking about numerical approaches complementing visual approaches, right? So they're not either or, they're mostly together. And you may want to look at visualization as a way to augment that outlier detection and say, is the z-score right, or am I just choosing something based on an assumption of a distribution, which may not be the case, right? So think critically about your data, try and visualize it to understand what the shape is. Just don't rely on numerical summaries, and put them together, right? It's not either or, nobody's competing here, right? Yeah, a few more before we wrap up.
Yeah. What are the most cost-effective tools for visualization, ideally easy to learn and implement?
Okay, so I mean, we talked about a few approaches to visualization here, right? Let me just open maybe some map which may help us talk through it. I'm gonna. There's probably a more deeper stuff on this. I'm just going to talk about different ways to think about creating visualization, especially interactive. And then we can chart some tools on this, right? So primarily the best tool, the most cost-effective tool for creating visualizations is a tool that you know and you're comfortable with, right? So go with what you know, and most visualization tools can actually be stretched far more than you may know about, right? So they're obviously far more capable. I spent my first 10 years in consulting doing stuff on Excel and PowerPoint, and we can do fantastic stuff just on those visualization tools. So my first advice is to understand a tool that you're comfortable with and see how far you can push it, right? Then if you want to think about visualization in a slightly deeper way, we can think about charting tools. So tools that have a lot of chart templates that allow you to create visuals. And their, charting tools could be Excel, and they are all charting tools. But you can also have various JavaScript libraries, various tools in R and Python. They're all charting tools that can actually fit it in this bracket, right? So depending on, and since we're saying low cost, most open source tools are free. So anything in R and Python, Plotly, Boca, Matplotlib in Python, anything in R, ggplot. No, not ggplot, but the other libraries are in the charting category, right? The second category is kind of the grammar-based tool, which is kind of this big bucket in the bottom, in the middle, right? And grammar-based tools are what we were talking about, allow you to create much more expansive visualizations. And there you have tools like, grammar-based tools. Let's think of ggplot in R, Altair in Python, D3, or Vega in JavaScript, or the Vega ecosystem in JavaScript. Those three are all kind of declarative grammar-based. Declarative in the sense you don't need to define a lot of stuff to create visualizations, right? And if you're not comfortable with a simple declarative code and you want to use something more expressive, you can go down to a more imperative code kind of thing. So you can think of, D3 has pretty much the imperative code way of doing it and very expressive, and you can go down to that kind of library as opposed to a specification based library. Or you can think of visual tools which are grammar based. Since you said free, I don't know, but Tableau is free for public data. But so most of the Tableau tools are, Tableau is a pretty visual tool, which is free. But many of the other grammar-based tools there are also in it. Power BI, for example, from Excel, from Microsoft, is somewhere in the middle of, it's a visual tool, but it's a little more focused on charting, but it allows you to create more templates. So you can think of it as somewhere spanning grammar and charting. And I'm focusing a little more on kind of data analytics side of it. And then if you want something that's really expressive, you may want to use something that's pixel rendering. Like you don't have any constraints, and you can take any different data form and design every pixel, and you're basically painting on a canvas. And in tools here would be, the ones I would think of is P5.js, processing. Those are the pretty common ones which intersect between art and infographics and visualization. So hopefully that kind of helps you think about it. So think about charting stuff that you're good at. think about grammar-based tools that you can pick, which may help you to expand your scope of visualization. And then if you want really expressive stuff, go to pixel-based tools like P5 and processing, right? And then think of how you're comfortable accessing these tools. So, you want visual UI on it, then pick one of those. Or you want a declarative language, pick that. Or if you're okay coding imperatively, then, T3, nothing beats T3 at that stage. Okay.
Looking at the time, Amit, let's have this one as the last question, because really
Sure.
we are running short of time, paucity of time. So the last question is, what is the difference between data visualization and data analysis?
So let me go back here, right? I mean, like I said, this is a very simplified version of data analysis, or the path that you take for data analysis, or the path you may take for any kind of analytical way, or even to some extent for creating something which is an infographic. In essence, you have to do all of this. You have to define the problem, you have to get the data, you have to explore it visually, you have to transform the data, you have to model it, you have to then share it back in a way that communicates. And visualization plays a part in all of this. And you can think of visualization as just another thing in your armory to do that. So there's no difference from data analysis. It's one thing, one element that you use to understand what's happening in this process, right? And along with visualization, you will also have other non-visualization libraries to access data. You want to get data from databases, you want to load the data, you will have data to model, and those libraries are not visual. They're going to be doing the data modeling or processing, or creating an ML model, or creating a simple correlation model, whatever. So the idea is it's an integral part of this entire process, and visualization is embedded in it in terms of how you do each one of the steps. So it's not any different in either ways, right? I think we need to end right now. I cognizant of the fact that we kind of covered a little bit, but I'm going to just leave that page open. I'm pretty much at amitcaps.com, and I'm going to be putting this deck up if you're interested on Speaker Deck also. And, feel free to reach out to me through any of the channels mentioned here. If you have more questions or you want to discuss more, here, Twitter, email, anything that works for you. Right, so I'm there, and yeah, thank you for spending 1 hour with us, asking a lot of questions, keeping it interactive. Hope you got something out of it, and thanks, Ankita and NASSCOM, for inviting me to talk to you, all of you.
Thank you, Amit, for this wonderful as well as interactive session. It was quite an interesting one. I'm sure the takeaways are great for everyone. Again, I just want to tell you all of you one thing. We are initiating a new series in product management, and tomorrow we have an introductory session by Ram Narayanan, VP and MD at VMware India, on product management and marketing in the age of digital transformation. At the same time, 14:30 to 15:30 hours. Stay tuned. See you tomorrow. Thanks a lot, Amit.
Thank you, Ankita. Bye.
Thank you. See you, all of you. Bye. Take care.